Among the currently known almost 795,000 minor planets on a direct orbit around the Sun, there are currently only 5 dwarf planets, which, according to the definition of the International Astronomical Union (IAU) from 2006, have sufficient mass and gravity for a spherical shape, and unlike planets and according to the planetary discriminant, do not have an orbit cleared of celestial or small bodies such as asteroids and comets, as well as meteoroids. Despite the constant criticism of the definition criterion of the adjusted environment for the distinction of planets and dwarf planets, as well as its limitation to our solar system, the concept and the number of dwarf planets are accepted by the majority of researchers today. The category thus includes Ceres, the only dwarf planet in the asteroid belt, and the celestial bodies Pluto, Eris, Makemake, and Haumea, which are classified as so-called Transneptunian dwarf planets, or plutoids. The former, with its discovery date on January 1, 1801, and its equatorial diameter of 964 kilometers, is also the oldest known and smallest dwarf planet. It owes its name to the former Roman goddess, Cerere Ferdinandea, for agriculture and fertility. If you like our videos, please support us with a thumbs up, subscribe to Simply Space, and look forward to the videos that will be waiting for you in the future. Calculating the orbit of Ceres was once an astronomical feat. Ceres was discovered by the Italian astronomer, mathematician, and priest Giuseppe Piazzi, 1746 to 1826, who was the first director of the Osservatorio Astronomico di Palermo, founded in 1790 until 1817. His discovery made him a foreign member of several academies of science in Germany and throughout Europe. In his honor, the asteroid 1000 Piazzi, discovered in 1923, and the moon crater Piazzi, a good 100 kilometers wide, were named after him. At first, Piazzi, his comrades in arms, and successors thought that Ceres was a comet or asteroid, and only after the orbit had been determined by the German mathematician, astronomer, and physicist Johann Carl Friedrich Gauss, 1777 to 1855, did they think it was a planet. The KQ method for determining orbital points under the premise of the shape of an ellipse, which was used for the first time by the world-famous Prince of Mathematicians and is still highly revered in the professional world today, revolutionized astronomy at that time. The old astronomical symbol of Ceres was a sickle, similar to the Venus symbol, but interrupted, which was later replaced by the general asteroid symbol of a numbered disk. First classified as a new planet, Ceres later received the status of an asteroid. The categorization of Ceres has changed several times since then and has been the subject of disagreement among astronomers. For example, the German astronomer Johann Alert Bode, 1747 to 1826, who later became famous for the Titus-Bode series, considered Ceres to be the missing planet between Mars and Jupiter at a distance of 419 million kilometers from the Sun. Ceres was soon assigned its own planetary symbol, and like 2, Pallas, 3, Juno, and 4, Vesta, was listed as a planet in astronomical books and tables for half a century. However, when towards the end of the 19th century, numerous other star-shaped objects were discovered in the immediate vicinity of Mars and Jupiter, for which the German-British astronomer Friedrich Wilhelm Herschel, 1738 to 1822, had proposed the designation asteroid as early as 1802, it was slowly realized that Ceres was the first of a new class of such objects. A short time later, Ceres lost its previous status as a planet and from the 1860s onwards was listed under the new designation 1 Ceres as minor planet, planetoid, or asteroid. The chemical element cerium, zero or cerium from the group of lanthanoids and rare earth metals discovered in 1803, was named after Ceres because it had only been discovered shortly before. Space Telescope and Dawn have brought Ceres even closer. Since the 1960s, the size of Ceres has been specified as between 650 and 1,000 kilometers in equatorial diameter, depending on the method of measurement used. Only through observations with the Hubble Space Telescope in 1995 and the Dawn space probe between 2015 and 2018 is the exact size of 964 kilometers precisely known. The images taken by the Hubble Space Telescope in 1995, 2003, and 2004 showed a dark spot on the surface of Ceres, appropriately nicknamed Piazzi, and several other circular shapes, initially thought to be purely crater-like. In 2006, several years before the Dawn spacecraft made numerous new discoveries, Ceres would almost certainly have been declared a crater again as part of the debate about Pluto and the question of what exactly constitutes a planet. In view of the IAU's already mentioned and more narrow definition, according to which Ceres is not a planet because it does not dominate its orbit, it was instead declared the first of a total of 5 dwarf planets. The poetically named Dawn probe of the U.S. National Aeronautics and Space Administration Discovery Program for Space and Aviation Science has provided numerous and valuable insights into the nature of the inner solar system, as well as the asteroid Vesta and the dwarf planet Ceres. The exploration of the cosmic dwarf was carried out in small steps over years. After initially providing a large number of detailed images and topographic data on the composition of Vesta's surface between May 2011 and August 2012, the spacecraft finally began its approach to Ceres in early September 2012, arriving in high orbit in early March 2015. By July 2015, the spacecraft was gradually approaching or descending for primary mapping of the planet's surface. Between December 2015 and June 2016, a second descent was carried out at an altitude of up to 380 kilometers above the surface of Ceres, during which soil chemistry was studied in addition to more detailed mapping. In September 2016, Dawn returned to an orbit of approximately 1,460 kilometers, and between November and December to an altitude of 7,200 kilometers, where the previously acquired data was repeated, refined, and calibrated to include cosmic rays. In February 2017, the spacecraft climbed in an elliptical orbit first to 9,350 and then to another orbital plane at an altitude of 20,000 kilometers. In the spring of the same year, the position of the Sun just behind the probe provided further important insights. The dead space probe will hover over the water world for the next decades. When problems and failures of the reaction wheels occurred again in April 2017, the further observation plans and trajectories were changed with regard to minimal activity of the control jets and thus the consumption of the rocket fuel hydrazine. At the beginning of June 2018, Dawn was lowered to an altitude of only 50 kilometers above Ceres in order to observe its surface more closely. The ion thrusters were permanently deactivated on June 21, 2018. The Dawn mission was officially declared over on November 1, 2018, after fuel supplies were finally exhausted, so that the power supply was also interrupted and a last attempt at contact also failed. Since then, the probe has been in an uncontrolled but relatively stable orbit around Ceres as an artificial satellite and will probably remain there for at least the next 20 years. In August 2020, an extensive study was published with the data from the Dawn mission, according to which Ceres is a kind of extraterrestrial ocean world with a huge reservoir of salt water a good 40 kilometers below its surface. This large water reservoir was considered by astronomers and industry alike to be a great potential interest for a possible future use of Ceres as a source of water, oxygen, and fuel, as well as a transportation hub for the mining of mineral resources. The dark Ceres is virtually littered with numerous large and small craters. The said study also involves a complete listing and description of all geological formations on Ceres discovered during the Dawn mission with respect to the surface, crustal, and interior properties of the dwarf planet. The Ceres spectrum has features of carbonates and clay minerals that are usually absent from C-type asteroids, which is why Ceres is occasionally classified as a G-type asteroid. Due to the relatively high maximum temperature of -38 degrees Celsius, the surface of Ceres is quite dark compared to the icy moons in the outer solar system. The surface also has a large number of craters with low relief, suggesting that above a relatively soft surface, they are probably made of water ice. The largest impact crater with a diameter of more than 283 kilometers is the rather shallow Kirwan crater in the south of the Vendimia Planitia lowlands, whose floor and immediate surroundings are smoother and relatively flatter than the rest of the dwarf planet's surface. Many of the other craters have central pits and peaks, which may indicate that gases may have escaped after former impact. The volcano does not spew liquid rock, but rapidly melting ice. The 130 light-colored surface features cited on Ceres are now interpreted as areas with particularly high concentrations of salt or ammonia clays or brine. The numerous long, straight, or slightly curved canyons could be the result of the slow shrinking of the Ceres crust after its formation, when cooling and tensions broke the icy and rocky ground in certain places. The impact of large meteorites and space rocks is also cited as a possible explanation. Just as impressive as the canyons are the almost 24 and up to 5,000 meter high mountains and ranges on Ceres. The highest elevation is the geologically still alive cryovolcano Ahuna Mons, which instead of lava, ejects an easily meltable ice mixture, on the sides of which broad, bright salt strips run, and which is named after the traditional post-harvest festival Ahuna of the East Indian people Suminaga. Similar in distribution, age, and shape to the Ahuna Mons are the two other imposing elevations on Ceres, the Yamor Yasolo Mons near the North Pole and the Liberalia Mons near the equator. Ceres is the namesake for places all over the world and many cultural products. The dwarf planet Ceres, now known for more than 200 years, has been firing the human imagination in naming cities and towns in Argentina, Australia, and Brazil, as well as in Italy, Scotland, and South Africa, long before the Dawn mission was closely examined. Airplanes, locomotives, and cars, as well as ships and submarines, were also named after him. The same applies to schools and programs in the field of education, beer and juice, sports and soccer clubs, and computer and software systems. As early as the 19th century, and up to the present day, Ceres has served as the plot or origin of stories, narratives, novels, and feature films, mainly from the science fiction genre. Comics, mangas, TV series, and computer games also often and gladly use the famous dwarf planet or its supposed inhabitants as an integral part of their dramatization. It remains to be seen whether and to what extent the celestial body, which has meanwhile been relatively well researched, will in fact and in the future be able to fulfill the numerous expectations and hopes placed in it, also in terms of economic use. Feel free to share your experiences and opinions in the comment section.